The first thing a German pilot noticed when he sat inside the cockpit of the new Focke-Wulf 190 wasn't the smell of oil or the tight fit of the harness. It was the wings. Broad, thick, brutal. They looked nothing like the graceful elliptical lines of the Spitfire or the long-limbed Messerschmitt Bf 109. They were squat slabs of steel and rivets, more like industrial blades than aerodynamic art. They were also the reason why dozens of Luftwaffe pilots nearly died before even seeing combat, because the same butcher bird wings that made the Fw-190 legendary in air battles over France and Russia also hid a lethal instability that its own designers barely understood. In the summer of 1941, when the Fw-190 first entered operational service with Jagdgeschwader 26 on the Channel front, German propaganda hailed it as the fighter of the future. Powered by the BMW 801D2, a 14-cylinder radial engine producing 1,700 horsepower, it could reach 408 miles per hour at 20,000 feet and climb faster than almost any Allied fighter. Pilots called it a dream. Heavy armor around the cockpit, wide-set landing gear that avoided the Bf 109's notorious ground accidents, and four 20mm MG 151 cannons mounted in its wings that could saw a bomber in half in seconds. But beneath that mechanical confidence was an unspoken fear whispered through Luftwaffe flight schools. The 190's wing could kill you before the enemy ever would. The trouble began in the design offices of Focke-Wulf at Bremen in 1938. Chief Engineer Kurt Tank wanted a power wing concept, thick enough to hold fuel, guns, and landing gear all in one integral structure. His designers, under Ober-Engineer Ludwig Mittelhuber, calculated the load factors to handle 8.5 G at 700 kilometers per hour dive speed. On paper, it worked. In flight, however, the airflow over the outer third of the wing broke down violently under high-speed compressibility. Test pilot Hans Sander recorded the first near-fatal incident on October 5, 1940. The ailerons froze solid during the dive. Aircraft began to roll left without control, recovered only below 300 meters. Hans Sander, Test Report, Bremen Flight Log number 44, 1940. The engineers called it a shock stall. The pilots called it die Beißflügel, the biting wing. When the first production A1 models reached frontline units, the effect was immediate. During combat training at Le Bourget in June 1941, two aircraft from 2I JG-26 entered steep dives while chasing a captured Spitfire. Both disintegrated before recovery. Investigators found the outer panels had twisted upward 14 degrees before breaking off. At 750 kilometers per hour, that torque exceeded the metal's elastic limit by nearly 20%, yet no one dared ground the fighter. Germany needed it too badly. By mid-1942, over 1,200 Fw-190s were already delivered, each costing about 56,000 Reichsmarks, nearly twice the price of a Panzer IV tank.
To fix the problem, Tank ordered production lines to reinforce the wing root with an additional 32 kilograms of duralumin spar bracing. That solved one issue, but created another. The heavier wings shifted the aircraft's roll inertia. Pilots now found themselves fighting the controls at high altitude. At 25,000 feet, the stick shakes violently, noted Lieutenant Walter Novotny after his first Eastern Front mission, as if the airplane resists its own pilot. Lieutenant Novotny, Combat Diary GG-54, December 1942. Fatigue rates rose sharply. Maintenance crews discovered microcracks near the gun ports after only 100 flying hours. By winter 1943, nearly 1 in 5 FW-190A4s required wing panel replacement before reaching 200 hours of service, an astonishing attrition rate for a front-line fighter. Still, Luftwaffe command couldn't abandon it. The 190 was their shield against Allied bomber streams. With the Bf-109 now outmatched at altitude by the Spitfire Mk9, the Butcher Bird became Germany's workhorse interceptor. Its broad wings allowed it to carry 500 kilograms of ordnance, bombs, or extra fuel, transforming it into the Fw-190F and G ground attack variants that struck Soviet armor near Kursk in July 1943. But again, the very structure that allowed it to bear heavy loads made it terrifyingly unpredictable in dives. Pilots learned to pull out no lower than 1,500 meters or risk wing snap. Veteran ace Otto Kittel, credited with 267 kills, once quipped to his mechanic, "She kills fools faster than she kills Russians." O. Kittel, Hangar Log, Oral Front, 1943. Technicians tried aerodynamic bandages, adding a small leading-edge fillet, stiffening the aileron hinges, and adjusting the outer spar web thickness by 2 millimeters. It worked marginally, but as production accelerated, 3,500 units built in 1943 alone, quality control collapsed. Wartime shortages forced factories to substitute inferior aluminum alloy from Czech suppliers. Records from the Soro plant show rejection rates of 18% in wing assemblies by late 1944, compared to only 4% in early production. Some planes reached the front with uneven torsion stiffness between left and right panels. The result, violent roll oscillations in high-speed turns. By the time the Allies invaded Normandy in June 1944, the Luftwaffe was losing not just air superiority, but pilots faster than they could train replacements. Flight training had been cut from 240 hours in 1942 to barely 110 hours in 1944. Rookie pilots climbing into a 190 for the first time barely understood its quirks. Many never survived their first sortie. Unit logs from JG-2 Richthofen list 17 non-combat wing failure losses between May and August 1944. The RAF's after-action reports describe German fighters rolling out of control without hits observed. Allied pilots often assumed flak damage. In reality, the Butcher Bird's own design was devouring its young. In the desperate months that followed, Kurt Tank's team experimented with a radical fix, the long-wing Fw-190D Dora, powered by the liquid-cooled UMO 213A engine. The new laminar flow wing and stretched fuselage reduced drag and redistributed stress across a wider chord. Dora pilots immediately noticed the improvement. Hauptmann Karl Baer wrote, "At last she flies like she wants to live." But production came too late. Only 1,800 Doras left the lines before Germany's surrender. By then, American P-51 Mustangs roamed the skies in formations of hundreds, each capable of escorting bombers from England to Berlin and back on a single 1,600-liter fuel load. The Luftwaffe's technological refinements meant little against that numerical avalanche. Yet the irony endures. The Fw-190's wing, conceived as an engineering triumph, embodied the very contradictions of the Third Reich's war machine: brilliant design constrained by industrial chaos, and technological daring undermined by desperation. Each rivet told a story of diminishing resources. By 1945, the average Fw-190 contained steel sourced from captured Czech stockpiles and recycled aluminum from downed bombers. Fuel shortages forced pilots to run engines on 87-octane substitutes instead of 100-octane C3, reducing climb performance by nearly 15%. Even the wing bolts, once precision-forged in Bremen, were replaced by cast units from makeshift factories in occupied Poland. Still, pilots clung to their aircraft with something like devotion. In the last weeks of the war, as the Red Army closed on Berlin, GJ-301 flew night interception missions against RAF Mosquitoes. The ground crews preheated engines with open fires beneath the nacelles, the air filled with smoke and frost. The wings, dark against the snow, gleamed with frost-etched scars from years of overstress. Many pilots never made it back. "She shuddered once, then tore apart in the cloud," wrote an anonymous ground observer at Rechlin on March 21, 1945, describing the final flight of an Fw-190A9 prototype. "It was like watching a bird break its own wings." After the war, Allied engineers studied captured Fw-190s extensively. British tests at Farnborough measured the torsional rigidity of the wing at 3,400 foot-pounds per degree, far below the Spitfire's 4,500. American reports noted that the heavy wing loading of 43 pounds per square foot made it formidable at low altitude, but unforgiving in stalls. Yet they admired its rugged simplicity. When the U.S. Navy designed the F-8F Bearcat, many of its structural ideas, short wingspan, wide gear, high power to weight, were drawn directly from the Butcher bird. What Germany's engineers had risked lives to discover became global aviation knowledge. The Fw-190 remains one of the paradoxes of the air war. It was feared, fast, deadly, and fatally flawed. Its wings symbolized both the reach and the recklessness of German engineering under total war. In the end, the Butcher bird didn't just cut through Allied bombers, it cut into the future of aerodynamics, teaching lessons written in broken metal and lost pilots' names. The Luftwaffe wanted wings of steel. What it got were wings that reminded mankind that every edge in warfare comes sharpened on both sides.